Welcome to quantum chemistry. And where do you think quantum chemistry is going to start? How about our favorite element, hydrogen? And what quantum chemistry mostly is interested in is electrons. Why electrons? Well, the electrons are the things that bind stuff together to come up with molecules. Electrons tell us what behavior the chemistry has. Why do you think this periodic table has this kind of setup here? Let's look at hydrogen. What does it have? Oh, it just has a little red circle. Now, I'm not too much for pictures. I think pictures kind of mess us up. But if you want to look down here, there'll be a little picture of orbitals. And what I'm really interested in is this thing down here where it talks about an N, an L, and an M. Those three values are the quantum numbers that tell us about the electrons, so we can come up with energies and stuff like that. The N is the principal quantum number. Now let's see if we can find other elements with different principal quantum numbers. Let's go to helium and see what happens to those numbers. Well, I went to helium and there's no change. And helium is one of those noble elements, so it's completely filled. And if you look at this little picture over here, see this little arrow up and arrow down? Those stand for a certain property of electrons that's really important in quantum mechanics and quantum chemistry, and that is spin. So the spin has a paired electron. So you'll notice in each one of these pink squares, the best you can come up with is 2 electrons. So this S block, let's see if there's any sense to this S block and the other colors on this page. Well, it seems that the S block is right in this area, isn't it? So each one of these must have a similar relationship. Let's try lithium, for example. Here's lithium. You got 1 2s, and guess what you think beryllium's going to be? Well, that pumped that one up. Now what happens down here with sodium? Well, there's 1 pink up, and then here's the other pink down. Now, notice what happened in between times. Well, we've got these p orbitals that filled up. Oh, what's the p orbital? Oh, look at this. Look at the picture down here. It's got all sorts of crazy things. It's got these shells within a shell. What could that mean? Let's pick out something here with some p orbitals. I'm just moving around here so we can kind of get the idea of what's happening. The p orbitals, let's pick out good old carbon. Carbon's one I really am interested in, and it has a couple p orbital electrons, and they both point up, because they're unpaired electrons at this point. So this gets really fun. Now let me pick out some of my favorite elements. Hydrogen, of course, and carbon, of course, and because there's lots of carbon around, and nitrogen. That's major atmospheric gas, nitrogen. And oxygen, Nitrogen is most of the atmosphere. Oxygen is a much smaller percentage of the air. And what else do we have? What other elements are really important to us? I had hydrogen, oxygen. We can come up with water that way. Nitrogen, carbon dioxide. Okay, that's really important. That's something that's all around and everywhere. Let's see another element that's really important. I'm going to pick out some elements that you might not think would be important. Here's copper. Copper has one unpaired electron. Silver, one unpaired electron. Gold, one unpaired electron. Plus gold has that F block. So that's really getting deep into the elements. So let's just kind of stick with these: copper, silver, gold. I'm going to pick on these because they only have one unpaired electron, just like the starting point, hydrogen, one unpaired electron. What we want to do is figure out this weird thing, spin. And this will get us deep into quantum mechanics. We'll even have to use Hilbert space just to talk about this little spin property that's only going to be up or down.